Hello everyone. Welcome to the first video of me talking to people. There is a reason that I make this video. Number one, it's quarantine period because of COVID-19, and I'm bored just as other people else. And second, I always wanted to tell the story of how I solve competition problems, be it math or programming, and I have done it a few times on my WordPress and sometimes on other media. But now I think that it's good to have some live video about it. So the competition of the day is the Google Code Jam 2020 qualifying round. Um, as you can see, I got a perfect score on this qualifying round and was ranked 222 out of 30K people. But frankly speaking, it is not that important because we have a lot of time to solve these problems. And in fact, I used a few hours to solve the last question. What that was pretty tedious and difficult to think about the solution at the same time. And we only need like 30 points to get into the next round, so it doesn't really matter like what ranking we are placed with. Now that being said, let me start doing showing you the first problem, which is worth 7 points, and it's good for warm out. So what this question is saying is that you are given a matrix, and this matrix is n by n square matrix, and it contains integers between 1 and n. There are a few tasks that we need to solve in this same problem. Number one, we need to find the trace, which is the sum of the diagonals of the diagonal entries. And number two, we also need to see how many rows have repeated values and how many columns have repeated values. To make it more concrete, right? We have repeated values mean if there are two elements that appear more than one element that appears more than one time. So if you look at this example, the sum of the diagonal entries, which is 1 1 so the trace is 4 in this case because it is the sum of all the ones, and we can see that there's no repetition in each row or each column, so the answer is 0 here. For the next one, each row and each column has repeated values, which turn out to be 2 all the time. So all the number of columns is 4 and the number of rows is also 4, so we just output 4. And let's see how would you do it. So this is pretty straightforward. We just need to use a counter to store the values. Okay, so let's see what the input format looks like. So we have the number of test cases, and yeah. So what should we do first? The input. Okay, so we have all our inputs right now. Let's see what are the tasks. The first task we need to do is to count the trace. So we initialize our trace to 0. So this is quite straightforward. We just look through all the diagonal elements and keep increasing the counter. Okay, the second task is to check the number of repeated columns and repeated rows. So how should we do it? Since we know that everything is between 1 and n, we can just we can just use an array of let's say 1 to n, and keep track of the number of occurrences of each number. And once we see any number that is at least 2, then we can just stop and add a count. So yeah, actually let's use a vector, because if we can, it's easier to increment the count. So sorry, I mean to initialize it. So what this code does is that we look through the we look through the ith we look through the ith row, and let's say and then let's say the numbers are like here 1, 2, 3, and 4. So we increment the count at 1, the count at 2, the count at 3, and count at 4. If you look at this example 2, 1, 3, then we increment in this order, like 2, the count of 2, the count of 1, and the count of 3 at the same time. Which means it might be a good idea to put n plus 1 over here, because otherwise, if your number is n and you have like only n space, you'll go overflow, because it's 0 indexed. So and if the frequency becomes more than 2, we just do I should also say that we might also need this count. And at this point, you can probably break from this subloop. And the next one, we also need to do the same thing for column, but the code is almost the same, except we are changing. We are looking at the ith column instead, looping over the ith column instead of the ith row. So we just have to change the position of the index. And of course, don't forget to change this as well. And now we are ready to print our output. Okay, let's test the program. Okay, that's there are something funny. Oh, wait. Okay, I guess it's okay. Looks good. Let's try to submit. Meanwhile, I guess we can have a look at the next problem. So this is another problem that I uh, that I got. Mm, okay, yes, the previous submission passed. So yeah, we can close this tab. So what this question says is that let's say we are given a string s which are all digits. Here we have 0, 0, 0, 0, 1, 0, 1, 1, 1, 1, 0, 0, 0, and 1. We need to add the parentheses or brackets, if you like, such that the brackets are balanced, and for each digit, let's say this digit is 1. There are exactly one pair of a matching bracket that surrounds it. So if the number is 0, then we shouldn't have any matching bracket that surrounds it. And if the number is, let's say, 3, there should be three layers of nested bracket that surrounds it. So what does it mean by a balanced bracket? So it means that the number, first of all, the number of open must be the same as the number of closed. So for example, this one, and this is a balanced bracket. This one is not a balanced bracket because there are more there are more closest compared to open. But even so, this is still not all the conditions for you to be balanced. So this one, it has the same number of closed and open, but it's not balanced because we also want that for every prefix, meaning that if you count from the first character to somewhere in the middle, the number of open must be more than or equal to the number of open. So if you just count this one, there's only one close and 0 open, so it's not bracket not balanced either. Okay, so for this one, the trick that works is called the greedy algorithm. So if you look at this this example 101, what it does is that let's say we have this 101. So we know that there must be one layer that surrounds this one. So we will add one of them to surround it. And now this 0, now the next character is 0. And we know, I should say that the task is not only to make the parentheses or brackets balance. We also want to minimize the characters we add. So in this case, right, there are two pairs that we add, and we need to add as little as we can. So intuitively, we only add the brackets if we need to. So for example, this digit 1, we know that there must be one bracket that comes before it, so we just add 1. We shouldn't be wasteful and do something like add this pair of bracket because it's not necessary and it will only increase our total count. So here, if we just do nothing here, we just do nothing over here, this bracket will surround this 0, and this shouldn't happen because the 0 means that we are not supposed to have any bracket that surrounds it. So we need to close it here and leave this empty, and the same theory goes here. So what happens if we have things like 1, 2, 3, 2, 1? Like just now we need to add 1 before this, so we'll add this. Now this one, this digit 2 requires 1 before it, one more before it, because there's only 1 here, so we just add 1 here. The same thing here, that's 3, and because there's this is only 2, but there are 3 open bracket, so we'll need to close this, and the same thing we will just need to close this. So this is just to illustrate the examples. To see how we should go by to code this, right? Yeah, the first line always the number of okay. So what's the next input? No, there's only one string. So this S is all the digits. So what if we want to go by the solution we discussed just now? One thing we can do is just to initialize the answer string, and we add the digits one by one, and possibly also if we need to, we also add the add the number of add some brackets. Now this means that it will be important to keep a counter of the number of left bracket that we have. Okay, so how should we go by? Okay, so we recall from above. Let's use this example. Let's say we have 1, 2, 3, 2, 1. Maybe we should comment on this. We know that the count is 0 over here, but we need 1. So let's do. What's that? Yeah, this is to extract the to convert this in from character to digit. Okay, so so count means the number of extra left bracket compared to the right bracket, and here we need to here obviously it means that we need to increase the count. So, but at the same time we also need to add the left brackets. And then the next thing we need to do is to add the number at si, which is a character actually. Now the next thing is that depending on circumstance, we might also need to close the bracket, but closing the bracket depends on the next character, and therefore we might want to do something like int let's say e equals to n. Now, there is a problem associated to this step. What if we are I is already at n minus 1 here, and we are this is n minus 1, which means the SI is this digit, and we are asking for the next for the next digit. It will just there's no digit in, and it will just return segmentation fault. So in this case, we want our digit to be 0, but we need to be a bit careful over here to check if I equals I equals n minus 1. So if it is 0, otherwise do this. And while count is greater than e, so let's say we are already at this stage. Now the count is 3, but the next digit is 2, so we need to minus 1 here by closing it. And finally, this should be a good solution, and we are ready to print our things out. Okay, let's test this. Oops. I'm not supposed to use n. This one, and this should be answer. Let's try it. Wow. That's pretty bad. Oh, yes, this should be the length of S. Yeah, hopefully this it will be right this time, please. Okay, this looks reasonable. It matches the sample output, which I hope this will pass. While waiting for this one, let's go to the third problem, and also the last problem that we'll talk about in this video. Okay, yes, it passed. Thank God. So for this one, the question is not the question. The implementation, at least for mine, is a bit annoying. So I won't go do the code walk type through. Instead, I'll talk about just the idea of the question. So this is this is a scheduling problem involving a couple, Cameron and Jamie, and they have a few tasks to do in a day. So for example, like they are one running from 18 to 20 hours every day, which is 6 to 8 p.m. The other one from 7 to 9, and the other one from 10 to 11. So the task is to ask you to split the task to these two people, the husband and wife, and such that none of the tasks are overlapping. So for example, if Cameron were to handle this 6 to 8 tasks, then the 7 to 9 task has to be handled by Jamie because Cameron was busy at 7 p.m. During this time. Now, assuming there are no other tasks, then both of them are free and anyone can handle this 10 to 11 tasks. Now, the question also asked us to say it's impossible to do so if it's impossible. So first of all, let's just first talk about the idea. When is it possible? So the claim is that it's possible if at any time there are at most 2 tasks. Okay, so what does it what does it mean? Let's take this example just now. So we take like 6 to 8 p.m. or 18 to 20, 19 to 21, and then 22 to 23. Okay. So how many tasks are there at, let's say, 6:30 p.m.? There's only one. If you ask for, let's say, 7:10, there are 2 because both these intervals span the 7:10 time. How about 7 p.m. Now this is a bit tricky because this is on the edge. So by convention we say that there are there are 2 tasks that spans from 7 p.m. because this starts at 7. So yes, there are 2. How about 8 p.m.? The answer turned out to be 1 because we don't count the endpoint as if you look at this example from let's say from 0 to 7:20 and 7:20 to 1440, then it's assumed that these 2 are not considered overlapping. Okay, so if there are a time that is occupied by 3 people, so let's say we have like 18 to 20, 19 to 21, and then 19:30 to 21:30, then this 19:30 is occupied by 3 tasks, which means that which means that there are only 2 people that can do the 3 tasks at the same time, which is impossible. But there's also another thing we need to justify to ourselves is that if at any time there are only 2 events going on at the same time, then we can then it's possible to assign the task to these both people. So to understand this, we need to use we need to use a graph where we have the vertices are the tasks, and edges happen if and only if the 2 tasks overlap. And then the goal is to see goal, or rather identity. We can split the task if and only if this graph is bipartite. Okay, and what am I going to say next? If at any if any time anything is Okay, maybe this is not maybe this is not the right thing to claim. Mm. Oh wait. Oh yeah. This is true. Um, it's a bit hard to find to convince yourself about this, but we can we can show that if anytime hmm, yeah. Hmm. Yeah, you know what? Let's skip the proof for proof for now. Hmm. Okay. I guess I will just end this part of the video by this by showing how the implementation looks like. Okay. So how I implemented this is by using a lookup. So a lookup where the so this is actually a key value. Oh, shoot. Yeah, let me just copy it. So the lookup is actually a dictionary where the key is the time and the value, the task number, and whether it's and status. So by status I mean that whether it's ending or it's beginning. So let's say we have like let's say the first task that we showed just now. Let's say it's like 1800 to 18 hours to 20 hours. So well in this in our code it is shown as minutes, which so this is basically 18 hours means 18 times 60, but don't worry about it for now. So in this case we'll do like lookup 18 hours uh, is the same as the 0 0. So this 0 means that it's starting, and this 0 means it's the 0th task, which is the first one. And we'll also do something like lookup so this is this is -1, which means that the task has ended, and this last 0 means yeah it's task 0, same thing. But the only the only problem is that what if you have like another task that starts at like let's say you have another task at like, then you have to do something like which means that once you do this the previous value will get overwritten, which is why instead of doing this like just pair I the value is actually an array of these things, which is why you can see that there's this factor here, and every time we will just add the elements back. Now how would this dictionary help us? Let's see. So here we predefine the answer where C means it's supposed to be taken care by Cameron, and J means Jamie, U means whatever that is undetermined, say. So this means so we also define a set cur means that current task in action. Now what we could do is to look through the time frame and determine like at this time at what time which of the tasks are being added and which other tasks are being removed. So in this case we can conveniently track like what's the what's the size of like sorry not size, like at each time like how many tasks are ongoing. There are also a few technicalities. Like let's say we have just in case like there are like a few tasks that that end like ended at the same time, and at the same time there are also a few tasks that starts. We want to make sure to pop the ending task first before adding the starting task into this current task set. So which is also the reason I have this with this -1 over here, because when we have -1 here and 0 here, and once we sort it, then this -1 will be guaranteed that it will go to the front, where this 0 will go to the back. So we can make sure that we always pop and for each time we always pop first before the before we add, which is why this so this sub lookup is the status of task at a particular time. Okay, so this one means status. Now we are looking at each individual item, and this one means what is the index task number, so to say. If we pop it off, then frankly speaking, nothing needs to be done except we just pop it. If we were to add it though, then we first see if the size is already at least 2. Then once we add it, it will be 3. So it will be invalid. So here, yeah, I forgot to tell. Valid means that whether our answer is valid. It is true by default until we see at any time we have at least 3 elements. Okay, the next thing is that if the current set is empty or there's only one element, then we also need to split the task on the fly right now. If it's empty, then it means that there's nothing that overlaps. That this new task has nothing to overlap with other previous tasks, so we can just let anyone to do it. It's 2020, and guys should do enough work, so we'll just assign to Cameron. Otherwise, we will check if Jamie is the one that is doing the work right now, then where this one refers to what is already there in the set. If that task is currently handled by Jamie, then we'll have to let Cameron to handle this new task. Otherwise, Jamie will handle the task since Cameron was already in other tasks. And I guess this is all the steps we need. And after that, just output everything. And since I didn't write this code from scratch, this was copy fresh from my submission, it will pass. So yeah, that's all the video for today. Hopefully I can make the video for the remaining 2 questions, which are a bit more way more complicated in fact, shortly.